Hi, my name is Sasha Powell, and this is my lab report for Physics 2212 Lab 4 circuits. The purpose of this lab was to compare and contrast the behavior of circuits with resistors in parallel and series, and to prove the loop rule. Some fundamental principles are Ohm's law, the loop rule, and the node rule, and my results were that the loop rule and the node rule are correct. I chose the system to be the circuit and the surroundings to be non-existent because I'm doing the virtual version of this lab, and the real life version it would be everything else except for the circuit. And my prediction was that my results would align with the node and loop rule. What will the ammeter readings be if I connect two ammeters to two 1.5 volt batteries and two resistors? My prediction was that they would both be 0.02, and they were. Will the readings change if one of the ammeters is inserted in backwards? It will have no effect. If I replace one of the ammeters with a voltmeter, the voltmeter read -3 volts and the ammeter read 0. The voltmeter reads a difference of 3 volts because the batteries are each 1.5 volts. The ammeter reads 0 because the voltmeter doesn't close the circuit, so there is no current. These are my measured potential differences across the circuit, and I was able to verify that the loop rule is correct because when I added them up, they equaled 0. Why doesn't the ammeter reading change when I attach the voltmeter? It's because the voltmeter does alter the voltage, but it has an infinite resistance, so it ultimately has no effect. What happens to the readings on the ammeters when one is placed in parallel instead of series with one of the resistors? The reading on both is higher because the current will flow through the ammeter instead of the resistor, because there will be less resistance with the ammeter. These are my calculations for potential difference measurements. The 47 ohms resistor had a resistance or a potential difference of 48 ohms. The 100 ohms resistor had a potential difference of 102 ohms. The wire had 0 and the ammeter had 0. All of these were calculated using Ohm's law. My results for the RC circuit was that when I first connected the battery, to the battery and the capacitor, the bulb was bright at first but dimmed over a short amount of time. The charging of the capacitor took 6.65 for the 10 ohm bulb and 10.12 seconds for the 20 ohm bulb. The current eventually became 0. When first connected to the capacitor only, the bulb was bright at first but dimmed over a short amount of time. Discharging of the capacitor took 7.35 seconds for the 10 ohm bulb and 12.93 for the 20 ohm bulb. Current eventually became 0. So charging and discharging was less amount of time for the 10 ohm bulb than it was for the 20. These are my results. I had a graph obtained by plotting the natural log of V over V naught, or V0 against time to find RC, the time constant. And my calculated RC was 6 seconds, and the RC that I got from the graph was 6.02 seconds. So pretty similar. Some assumptions that I made, or one assumption that I made, was that the voltage of the current is assumed to not be altered by the voltmeter. And this causes the source of error because the voltmeter actually does have an effect on the voltage of the circuit, which would make the readings inaccurate. A solution would be to calculate potential differences instead of using the voltmeter. My answers to the questions: what if I was doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? Is that the current would be lower because the ammeter would have some resistance. And what if I was doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? The battery would instantly charge the capacitor because there would be theoretically no resistance in the circuit, and this could cause a small explosion. Thank you.